Yeah, hello this morning. So today we deal with our second exercise, and let me move there. So first of all, our inequality measures. So we are in the newspaper market, and we have 5 newspapers or news corporations with market share of 15% A, 10% B, 25% C, 20% D, and 30% E. Calculate concentration ratio 1, 2, and 3. What do we have to do? Any idea? What do we have to do in order to calculate CR1, CR2, and CR3? Hello, you're still there? Can you give me a feedback if you are still in the Zoom meeting? Do you hear me? Okay, so concentration ratio 1, 2, and 3. What do we have to do? Well, 0.3 over 0.9. Where does this idea come from? So with the concentration ratio, we want to show how the market is aggregated. So first of all, we look at the different companies and order them due to their size of the share. So what we then see is we have this one is the largest, second largest, third largest, fourth largest, oops, and fifth largest. And CR1 is then just the market share of the largest firm. So CR1 equals 0.3. For 3R2, we have to add up the market shares of the first and the second largest equals 0.3 plus 0.25 equals 0.55, and CR3 is then of course adding up the three largest firms. So these, and then we have 0.75. B, the Herfindahl index. Just have a look in your notes. How is it defined? Yes. So sum over I from 1 to n and over the market shares. So we obtain 0.3 squared plus 0.25 squared plus 0.2 squared plus 0.15 squared plus 0.1 squared. Since I'm not able to do this just with my head, I of course ask Excel to do this for me. So this is E2, A1. Now what we have is these market shares. Hopefully this works. Almost. And market share. So then S squared equals 0.15 squared and adding up all this. Equals 0.225. And see, interpret well, due to CR1 to CR3, since we have only a small number, oops, firms, the market seems with respect to especially CR3 equals 75% quite concentrated. But due to the Herfindahl index is much smaller than 1. This would be the maximum. Remember, Herfindahl index is just 1 over n and 1 with its values. We see that these 5 firms are not very different or do not differ very much with their size or their market share. We see that the firms do not differ very much in their market share. Okay, then let's go to the second task. In the second and the third task, we want to show some properties of the Herfindahl index. So show within a model of Cournot competition with n firms with linear marginal costs, the Herfindahl index of this market divided by the demand elasticity equals the sum of the market shares weighted with their profit margins. So first of all, do you remember what Cournot competition means? This is from oligopole theory. So I think you have talked about Cournot competition just with two firms. Or if you have entered my lecture in public finance, then we had in an abstract way the same kind of process when we looked at the prisoner's dilemma and the provision of public goods. So then let's think about two firms are competing. And competing in Cournot competition means with respect to which variable compete these two firms. Let's say we have two firms, I1 and 2. And they are dividing the whole market. So we have quantity, total quantity provided in the market is then X equals the quantity of firm 1 plus the quantity of firm 2. And we shall have a demand function P of X and both firms maximizing their profits given the quantity of the other firm. And we shall have just marginal costs, which are constant. Constant marginal costs then means that we have cost functions looks like C of x is just a constant Ci times xi. So now I have to identify what are the profits of our firm. What is profits? Pi of xi equals then, in general, what is profit? What are profits? Not in a functional form, but just in general. What are profits of a firm? Yes. And what is revenue? In our case, revenue consists always of two components. How do you calculate the revenue? Costs we already have here. This is our cost function. And now we need the first part, revenue. Yes. And so we have here, and here you have to keep in mind that the demand depends on the total amount, total quantity in the market, and this is then multiplied the price depending on the total quantity provided in the market times, of course, only my quantity I am providing as firm I or as firm 1 or 2. So we will have then here P of x, and here I write 1 x1 plus x2 times xi minus ci xi. And this, of course, we need now to maximize. And what do I have to do when I want formally maximize my profits? What do I have to do analytically? Yes, and then setting this to 0. So I have to calculate the first derivative, and this I have to calculate with respect to my quantity in my firm. And then setting this to 0, I have to do all the calculation, and this we want now doing in general. So now we are looking at n firms and not only at two firms. So then calculating the pi of xi with respect to xi equals 0. And now we change to n firms. And this just means that the total quantity x is just x1 plus x2 plus and up to xn, or just the sum of xi I equals 1 to n. But actually, we are, of course, always look only at calculating the derivative just at this formula, and then we see nothing conceptually really changes in this formula. Only here we have to insert the total sum. So now we have to calculate this derivative, and then we obtain from this here, we have here a dependence on xi, here a dependence on xi, and here a dependence on xi. So since we not definitely specified the demand function here, for the derivative of the demand function, we just write dp with respect to x. This is the total variable, and what is this function? So the sum where we have xi inside. What is the derivative of the sum with respect to xi? So if you suppose f of xi is sum, then we have to change to another index. J equals 1 to n df dxi equals then so to speak, take for example, you want to take the derivative of x equals x1 plus x2 plus x3 and so on with respect, for example, to x2. So calculating the derivative of this function with respect to x2. What do you obtain then? So let's say f of x1 is x1 plus x2. Coming back to the example with two firms, then is f prime of x1 Then you can take x2 as a constant, so you can think of a function f of x is x plus 3. Derivative with respect to x. Let's take f of x equals x plus 3. Then f prime of x is, yes, definitely. So we can just skip this inner derivative since it is just a 1. And then we have, of course, to multiply with the other part, xi plus product rule. What else we get from taking the derivative of this product, p of x times xi, with respect to xi? So what we have is p of x and, so to speak, x itself is a function of xi times xi. This is our function of xi, and we should calculate f prime of xi. Product rule, let's say f of x is u of x times v of x, then f prime is so this is u prime times v plus u times v prime. So u is p and v is xi. So this first part we already have here, and now we need the second part. So u itself, so p of x, and then v prime, so f of xi equals xi, and what is f prime of xi? So this is just the same as we have it here above, but we don't have here a 3, but a 0. Actually, in this case, nothing else changed. So again, we have for the derivative just the 1. So times 1 minus, and now we have the function f of xi equals ci times xi. So the question is now, what is c prime of xi? Here, put also in an xi. So this is something like f of x equals 4 times x. What is f prime of x? Since we should have constant marginal costs. 4, great. And then for c prime, just think that ci is just a constant and xi is your variable x. What is then left when you're calculating the derivative? So this is your 4 and this is your x. Done? Yes. So minus ci equals 0. Well, and then we are almost done, because this one we now solve for the profit margin, and the profit margin PMI is just defined. I'm selling my good for the price P, calculating from profit maximization, minus marginal costs divided by the price. So you can think of a market where you can sell your product for a price of 4, then you have maybe marginal costs of 3, and this 4 minus 3 is 1, dividing by the selling price 4 itself means then that you have a profit margin of 25%, 1 over 4. So this is just P minus Ci over T. And here, T minus Ci we have already here. So from this optimality condition, we obtain T, and now I take this P from fx minus Ci. This part we have to put on the other side, so equals minus dp over dx times xi, and now we have in order to get the profit margin, we have to divide both sides by P. So X and dividing this by P of X. Well, let's take this on another slide. Okay, not working. Why is it not working? Again, X. Now. And the minus sign here. So, and then we almost there where we want to be, since looking at our task, the demand elasticity we need in general. And what is the demand elasticity? Quite often written as epsilon xp. This is just the relative change of quantity divided by relative change of prices. Or if you go to the limit, then of course we have dx over x over dp over p. And then you see that we almost there. But here we have dp over dx and then over p. So this we can also write as dx over dp times p over x. And this, of course, is 1 over dp dx, taking the inverse x over p. So this and this we have here already. And in order to get this x here, we just multiply in a nice way with just a 1. So we write here minus dp over dx times x over t times, now we still have the xi over the total quantity in the market. And then you see that this one here is minus 1 over the demand elasticity. And now we are coming to the Herfindahl index. What is this? The quantity I'm selling divided by the total quantity of the market equals to what we are summing up in the Herfindahl index. You just gave me the answer in the beginning. So the quantity you are selling divided by the total quantity sold in the market. This is nothing else than the market share. So this quantity of firm I over total quantity, and this of course is the market share, and this we called SI. So then we obtain, this is profit margin PMI equals minus demand elasticity. And to get rid of this minus sign, quite often we just define, since we know that the demand elasticity is of course in general for normal goods negative, then also quite often we define this as minus or the absolute value. So in this case, if we define demand elasticity with a minus sign, then we can skip this minus here. Up. And skip all this here. So times the market share. And then we want to have the Herfindahl index. And Herfindahl index again was defined as the sum over the market shares squared. So we multiply this, not squared, but only SI. So then we obtain SI times EMI equals 1 over X epsilon SP SI squared, multiplying with the demand elasticity, we obtain xp times si dmi equals si squared. And in order to get in the end the Herfindahl index, we have to sum over all I. Since this is a constant, this we can take out of the sum, so we obtain epsilon xt sum over si tm I1 to n is sum over si squared, and this is nothing else than the Herfindahl index. These are the profit margins, and this is the market size. So we have then shown that within Cournot competition with n firms, the Herfindahl index equals demand elasticity in our market times the weighted sum, and the weights are the market shares of the profit margins. So here you see some connection between our statistical measure, Herfindahl index, which then can be interpreted as in a specific way in the Cournot competition model. Okay, and another nice property of the Herfindahl index we want to show here. Assume that a market of n firms with market shares Si, so that the Herfindahl index can be written as 1 over n plus n minus 1 times the unbiased variance of market shares. This we have also to declare here. Sigma hat squared should be the variance or the unbiased variance of market shares. Variance, how was variance defined? If I ask you what is the variance, let's just skip at this moment the word unbiased. If I just ask you what is the variance of a distribution, what would be your answer? You can also just have a look in the notes if you want. There I defined variance. But hopefully you have done it in your introductory courses in statistics, and hopefully the variable variance also popped up in quite a lot other lectures you have attended. Because maybe this is the most important variable in order to describe the dispersion or the volatility of a distribution. So variance is in general the sum of the squared deviation from our expected value in our distribution, and in descriptive statistics we use for the expected value just the average of a distribution. So sigma hat is then sum over 1 I equals 1 to n Si minus Sr squared, and now we have unbiased, and unbiased means now that we do not divide the sum by the number of our sample, but by 1 over n minus 1. And then let's take this formula and especially let's calculate n minus 1 times sigma hat. N minus 1 here squared times sigma hat squared equals just the sum, because this factor here cancels, Si minus S bar squared I equals 1 to n, and then we just multiply here our two brackets. So this is I equals 1 to n Si squared minus 2 SIS bar plus SR squared. Then the sum we can move in the summation sign within the sum. So we obtain I equals 1 Si squared minus sum and then I just interchange these two as bar as I plus sum as bar I equals 1 to n. And what is this already? Sum over squared market shares. You're still there? Sum over squared market shares is yes, great. So this is already what we want to have, since we want to show this equality of the Herfindahl index. And now we have to deal with these two sums. And let's take at first this sum here. And there we see that at this s bar squared, we do not have any index. So no index. What can we then write for this summation? So to speak, if you have the sum of I equals 1, let's say to 4, over the number 2. This is what? The sign here means please calculate the sum of 2 from I equals 1 to 4. So 1, 2 for equals I equals 1 plus 1, 2 for I equals 2, 1, 2 for I equals 3, and 1, 2 for I equals 4. So this is 2 plus 2 plus 2 plus 2 is 4 times 2 equals 8. And using this, what is then this sum in general? So then you have to identify your 4 as a n and your 2 as s bar squared. So this just means that we have to sum up the square of the averaged market size just n times. So this is then plus n times s bar squared. Here, of course, in this sum, we have an index I, but in this part again, index I, and here no index I. So this is then something like 3 times xi, I from 1 to 4. So since we multiply every variable with the same constant number, we can move out the 3 out of the summation. 3 equals 1i to 4 xi. So this is then 2 s bar squared times I equals 1 over si. And here we already identified the Herfindahl index. And now let's have a look at this summation. What is sum over si I equals 1 to n? This has a direct connection to S bar. How is S bar defined? The arithmetic average of the market shares. This is just the sum of all market shares divided by n. 1 over n, I equals 1 to n si. And if you take this compared to this, then I can write here if you multiply this by n and this by n, then this cancels here. And then we end up here with the same formula. So this is n times s bar. So we obtain hi minus 2 s bar times n times s bar plus n s bar squared. And this is, of course, then hi minus 2 n s bar squared minus plus n s bar squared. This is a 2. Here we have 1 and hi minus n s bar squared. And now we are almost done. Now we have only to think about what is s bar squared. So we have s bar is 1 over n sum xi. Remember, this is the quantity of firm I divided by the total quantity. But this down here, x itself, is the sum of all quantities in our market. So what we then have is 1 over n times sum over xi over sum over xi. But this, of course, is independent of xi itself. It's just the total market size. So this is 1 over n sum xi over sum xi. So this cancels, and we have S bar is 1 over n. So we end up with n with Herfindahl index minus n times 1 over n squared, and thus Herfindahl index minus 1 over n. And then we are done, since we have Herfindahl index equals 1 over n plus n minus 1 times sigma hat squared. If you take this, our starting part, and taking this one here. Okay, so these were two little more theoretical exercises in order to show some nice properties of this Herfindahl index. Why is it a nice property? Well, quite often we just provide, if we talk about a market or something like this, or about a distribution in general, then quite often we do not have the single specific numbers. So the sample data itself, but only the variance and the expected value or averages. Because this we are doing, we want to describe with our variables like averages and variance and moments in general, we want just to describe a data set of, let's say, 1,000 or 10,000 data points with just some single numbers, 1, 2, 3, 4 single numbers. And if we have these single numbers, then you see that we directly can deduce from knowing the variance and the average Herfindahl index. Okay, I think we stop here today and doing the other exercises on Monday.